Hi, I'm Tim Berglund with StarTree. Welcome to Pino 101, Architecture Cluster Management. Now, Pino is a distributed database with brokers and servers and any number of both of those components. Obviously, these things don't manage themselves. And you hardly want to put the burden on the user of the database to roll your own cluster management. That would be terrible. And so Pino has that built in the form of the controller. So the controller is a single node in a Pino cluster, potentially a small cluster of controller nodes for high availability, but one of them is going to be in charge, that functions as an Apache Helix controller. Now, we won't talk much about Helix in this course, other than to say that it is the cluster management framework integrated with Apache Pinot. And what do I mean by cluster management? Well, detecting a failed node, recovering from that failure, segment replication, segment assignment. We've got a new segment coming into the cluster. What server should that be stored on? If you've followed previous sections on tables and segments and brokers and servers, there are some unanswered questions like, how do we know what server a segment goes to? Well, that's the job of the controller. So it maintains all that global metadata, that's schemas, table configurations, mappings of, this table has these segments and these segments reside on these servers. All that stuff is what the controller knows. And it exposes an API endpoint, a REST API endpoint, for cluster administrative operations. If you want to add a table, you ask the controller. If you want to modify the configuration of a table, again, these are all things that you do at that controller REST API endpoint. And for real-time tables, where we're just ingesting from Kafka directly into a server, the controller is still involved in mediating that process. So very, very important cluster component. And as a result, like I said, it is therefore possible to configure the controller for redundancy, for high availability. There's only ever one active controller, but we don't want to wait around for one if that one goes away. So it's possible to have some on standby. And off to the side of the controller is a Zookeeper instance, doing what Zookeeper does. It's being distributed, replicated, fault-tolerant, strongly consistent, in memory, and also durable state store. So all of the metadata that the controller is responsible for, Zookeeper is the persistence mechanism for that metadata. The whole picture then looks something like this. You've got your servers, you've got your brokers, you've got your state store, you've got a controller, and of course you have a Zookeeper quorum or a cluster of Zookeeper nodes. And brokers, just showing symbolically 2 and 3 servers here, of course, those are going to scale out arbitrarily, as many of those as we want to handle the workload of the cluster. Multi-tenancy is in a lot of ways a cross-cutting concern in Pino, but while we're here thinking about cluster management, let's talk about how multi-tenancy works, because it touches on a lot of the same things. The good news is that Pino supports this natively. And what Pino means by multi-tenancy is we're going to have the ability for some tables to be hardware isolated from others. They will never share the same hardware. So the data in this table is going to be on this server. The data in this table is going to be on this server, and the two will never mix. Likewise, brokers, which aren't storing the data, but are brokering, query processing, same thing. I can ensure that for a given table, only these brokers will see those queries and broker the request and the response. For some other table, only this set of brokers will do that same work. This works through a tagging mechanism. So in the configuration for each broker and for each server, I can provide a tenant tag. And you see I have very creatively come up with 2 of them, and I've called them A and B. So some of the brokers are tagged A, and one of them's tagged B. 2 of the servers are tagged A, 2 of the servers are tagged B. And so a given table now can identify its broker and tenant tags that it wants to be associated with. So I'm just showing segments here. Let's not worry about what tables they belong to or anything, but they're segments of tables tagged for A versus tagged for B. And if they're tagged for B, they're only going to go on B tagged servers. If they're tagged for A, they're only going to go on A tagged servers. So in the table configuration, you get to say what server and broker tag you're willing to accept. And for brokers and servers themselves, they also have that as a part of their configuration. The controller knows all this. And so now when the controller is going to decide where a segment's going to go to, it can respect tenant tags and make sure that the data for those tables assigned to different tenant tags never mix on the same machine and the same storage hardware. So that's it for Pino cluster management. Remember, you've got the controller and Zookeeper, and just for good measure, a brief treatment of multi-tenancy.